Alright, so today we're going to try to answer the question about how do we find unknown parts of a triangle. See if we can get it there. So we had this problem on page 100. I'm not sure how far we got last class. Number 36. Does anyone remember how far we got on this one? This was your exit ticket. Okay, thank you. So let's go over the exit ticket. Thank you. So the exit ticket was number 36. You gave the area of a circle. It says the area of a circle is 25 pi, and you had a radius of x plus 3. So I did see a lot of little simple mistakes and kind of math work that was kind of all crazy, where you had stuff all over the place. So I want you guys to get more working down. So first thing you should do if you're talking about the area of a circle is write the formula for the area of a circle. Write the whole thing. Capital A equals pi r squared. And then from there, go ahead and fill in what you have. We know the area is 25 pi, so we fill it in for A. And we know that r is x plus 3, so I fill it in for r. Now this is where you have to be careful too. You're plugging in that whole value, x plus 3, into r. So that whole value is going to be squared. I think I saw some mistakes where parentheses weren't used and just 3 was being squared, which is a completely different thing. So then you got to here. I saw some of you had pi in your final answer for x, but notice here, if I have 25 pi equals pi times x plus 3 squared, my next step, you can already see, was just go ahead and divide each side by pi, right? This is being multiplied by pi. This is being multiplied by pi, so why not just divide those sides by pi and then arrive here? Okay, they have that same constant in common as a factor, so let's go ahead and divide each side by pi. So now you're here. Now from here, what do we have to do to start solving for x? Diamond, what do you think? Get rid of the exponent, and how would you get rid of it? Okay, so you're gonna expand this. Okay, so you're saying to get rid of it by expansion. That's good. So we go ahead and we expand that. Now just be careful. You said x squared plus 9. No, but here's the thing. When it says x plus 3 squared, go ahead and write it as x plus 3 times x plus 3. That way when you FOIL, you're going to get the right thing. So this is not x squared plus 9. So make sure you do it the long way so that you actually get what it really is, which is going to be x squared plus 6x plus 9. All right, you can continue to encourage to do it the long way. Okay. So then you go ahead and you do that, and you get to here, and then once you're here, what do you think you want to do next? What's the next figure? So you expand, you have x squared plus 6x plus 9 equals 25. What do you think is the next thing? Jesus? So we are this line right here. Well, you're careful, you're one step ahead. We can do that in a certain situation, yes. Subtract 9 from both sides. If we do that, that'll get rid of this 9, and this will become 16. You said minus 25, zero it out. That's what you want to do. Remember, we have to be in that form that we talked about. Ax squared plus bx plus c equals 0 before we do long AC or tic-tac-toe. And again, just to emphasize, long AC and tic-tac-toe mean do the same thing. So we go ahead and we want to get this to become 0. Diamond, so what will we do for this to become 0? You told me, wait, what? Okay, thank you, sorry. So subtract 25 from both sides. And Anthony, what would be the next step? We have x squared plus 6x minus 16 equals 0. Tic-tac-toe. Yeah, that'd be fine. Tic-tac-toe. You can go ahead and do that. So tic-tac. Once you get to the quadratic equals 0, tic-tac-toe, the quadratic part, the left-hand side, and you'll have the factors. Nothing, so go ahead and do that.
So do you not have to, since there's a 1 in front of the x?
Can you say that louder, please?
The 1 in front of the x, you don't have to do.
There's a 1 in front of the x squared, yeah? So we don't even have to do tic-tac-toe. When it's this simple, when it's a 1 in front of the x squared, right, I can technically write a 1 in front of it, but you know, even if it's not written, it's understood. Because of that situation, you can go straight to the linear factor. You go straight to the 2 sets of parentheses. So if we go straight to that, Jamie, what would it be? We went straight to the linear factors. X plus 8 and x plus 2 equals 0. Okay, so you have x plus 8 and x plus 2. Now, how can I check to see if this is right, Jamie? Plug what back in? You just took this and factored it out. How do I get this to look back to like this? How do we expand this? Remember the process when if you want to multiply this by this, what do you do? The process to do that? We did it here. FOIL. So if I FOIL this, you have what? X squared. You have x squared, right? Plus 2x plus 8x plus 8 times 2 is 16. And you have, that wasn't really necessary, but thank you. X squared plus 10x plus 16. Is that what this says? No. Okay, so this is a good example of when you factor, go ahead and check it right now. Make sure you see if you got it right, because you want to know if you got it right or wrong, right? Like before you go any further. Okay. So, Andriana, what do you think? Positive 8 and negative 2. And that is correct. And if you went and FOILed this, x squared minus 2x plus 8x, that's 6x. 8 times negative 2 is negative 16, so that is correct. Good. And so now we're here, and now the last, basically the variant here, we have this times this equals 0. So what does x equal? What do you think, David?
X should probably equal 8 and then 2. Or negative 8 and 2.
Negative 8 and 2? That's right. Negative 8 and 2. So these are, I know it's crossed out right now, but the negative 8 and 2, these technically are solutions to this, which were solutions to this all the way up. All the way up, they are solutions to this. But, yes.
I was going to say an easier way to do it without doing all that work. Just what plus 3 equals square root of 25.
Yep.
That gives it all that.
Yep, so if you can see, okay, what would I add 3? Well, what would this need to be such that when it is squared, it becomes 25? Yep, absolutely. So this is a basic problem where you can probably just see it, but the more complicated these problems get, it's going to be harder to just see it immediately. But yeah, you're right. Yes?
Is that plus 2?
So this is a, right here? No, that's a negative 2. So x equals negative 8, because if I plug in negative 8, it would make this 0, which makes it true. If I plugged in 2, it would make this 0, which makes it true. So I have negative 8 crossed out, and I have only 2 circled. Can someone tell me why?
So that's the only one that could probably fit in. Oh, yeah.
That's it. These definitely work for this equation, but think about where we started with this problem. We're talking about a circle. We're talking about x, which is, well, x plus 3, which is the radius of the circle. If we plug in negative 8 into x, what is the radius of the circle? Negative 5. That makes no sense. You can't have negative 5 feet or whatever. So that one doesn't make sense. Cross it out. You're left with the only one that does make sense. So plugging in 2 into x, 2 plus 3 is 5. All right, so 2 is the only one that worked.
I got the greatest common factor 25.
The greatest common factor of what?
25.
Just 25? Well, the greatest common factor of 25 is 25, but what do you mean?
I need to pick
Where is your paper? You turn it in? Is the exit ticket? Okay. Let me know at the end of class if you want to look at your work. I'll grab your exit ticket. But there is another way you can do this, and I don't recommend it because it's so easy to forget writing the plus or minus part. And that's from here. You wonder why there's nothing here because I erased it and I went up to here. If you took the square root of both sides here, that would undo the square root, and you just have x plus 3. The only thing is that you're going to risk forgetting to write plus or minus the square root of 25. And that's a risky thing to do. So I want you guys to stick with what you definitely are comfortable with, which I think is AC or tic-tac-toe, same thing. And just stick with that. Yes. Yeah, sure, please. All right, so let's look at trying to answer the question, how do we find unknown parts of a triangle? On page 100 on number 37. Yes. So number 37, we have the area of a triangle. This is on page 100. And it says the area of the triangle is 42, whatever square unit. Okay, so this is going to be approached. Just like when we did the circle one. So, Macy, do you remember the formula for the area of a triangle? Mm-hmm. No, it's exactly that. Good job. So area is equal to 1/2 base times height. You got it. That never changes. One way you can remember this too is that two triangles, if I took this triangle and I duplicated it and I turned it around, it would make a parallelogram. So that being said, if two triangles make a parallelogram, what's the area formula for a parallelogram? So if two of these make the area of a parallelogram, what would be the area of a parallelogram? What's that? Thank you. Base times height. 2 times 1/2, 1, so you're just base times height. A parallelogram is one of the most simple formulas, which is base times height. When we say base times height, we're talking about the height must be perpendicular to the base, just like here we have BH. The height must be perpendicular to the base, as it's being shown here. Okay. Let's see. Go ahead and we will go ahead and knock this out. So area, so we're just going to plug in values, right? The area is 42, so I'm going to let area equal 42. 1/2. What's the base of this triangle? Yeah, 2x plus 8. Make sure you use parentheses. It's that full value. And the height, again, make sure you use parentheses, is x plus 3. Okay. Or do you know what I'm making next? Yeah.
From true contracted or distributed, right?
Yeah, the 1/2.
And you get 2 in parentheses, or the 1/2 in the parentheses.
It's 1/2, yeah?
Yeah.
Okay. Yes. We can do that as well.
Why can't this combine
Well, the thing is, combined like terms, are these like terms here? The way it's written right now, like it's 2x plus 8, are they alike? Okay, but the problem is right now is this is contained with this, and it's being multiplied with this, which is contained. So you gotta obey multiplication before you go ahead and combine like terms. Eventually we will combine like terms, but we can't do it right now. But we can do. There's more than one way to solve this. I mean, you could multiply both sides by 2 if you want to get rid of the 1/2. You could do that. You could distribute the 1/2 to either this one or this one, but not both. Don't double multiply. Now, I'm going to distribute to whichever one works out if I can avoid fractions, right? If I distribute this 1/2 to this guy, I would get 1/2 x plus 3/2. I don't like fractions. But if I distribute to this guy, I would get x plus 4, right? 1/2 times 2x is x, and then 1/2 times 8 is 4. So I'm going to do that. But you could multiply both sides by 2. That's fine too, Macy. So you would get x plus 4 times x plus 3. Okay, they're still in parentheses because all I did was distribute this 1/2 into each term of this guy. So they're still in parentheses. Diamond, what would I do next? Multiply? Okay, what would I get? 2x. X times x. X times x is x. Jonathan? X squared. X times x is x squared. X times 3. 4 times x. 4 times 3. Yeah. Now we can combine like terms. Let's see if these are alike. So 42 is equal to x squared plus 7x plus 12 minus 42 on each side, so goodness thing set equal to 0. So x squared plus 7x minus 30 equals 0. I went ahead and I flipped it around to equals. You can do that at any point you want. Do that. That's fine. All right. From here, do I have to do tic-tac-toe? Why not? Because of the 1 in front of the x squared. Yeah. So I'm going to go right to it. Factors of negative 30. 10 to negative 3. Thank you. So x plus 10 times x minus 3 equals 0. Again, check it, make sure it's right. So now we can say that x plus 10 could be 0, or we could say x minus 3 could be 0. So now, what would be the solution to this one? 0? You don't know the solution to this? So you think the solution is 0, that means 0 plus 10 should be 0? Yeah, it'd be negative 10. Negative 10 plus 10 is 0. If we subtract 10 on each side, x would equal negative 10. And then solve for this one, how would you solve for it? Do what did you say?
3.
Add 3?
Yeah.
Yep. So there are 2 solutions, and it says to find x, but keep in mind we're talking about a triangle, so we got to make sure that both of these, we'll see which x's make sense. And this can't be a negative distance, and this can't be a negative distance either. So we plug in negative 10, boom, there's an immediate issue right there. Negative 10 plus 3 is negative 7. We can't have that. Can't have negative 7. That guy doesn't work. And then here, if we plug in 3, well, positive, it's all going to be positive, so this definitely works. So this is the only solution for x that works. So don't forget when you're dealing with real life problems like these, they have to make sense. Yes?
I just automatically plugged in 3 to all the x's and I solved it.
Yeah, I mean, as long as it works, yeah.
I mean, just 3.
Just make sure when you do your work for homework, quiz, or a test that you show some work algebraically. Because I need to see the foundation being built, so we have problems that are more complicated.
Okay. I just plugged in 3 off of that and it was correct.
I heard you the first time. Yeah. Okay. All right. So that was 37. So 38. Any questions about 37? Okay. 38. We have a trapezoid. And we have x plus 6 is this length here. And then down here, this length here is x plus 2. And then we have a height of x. And it tells us that the area is equal to 32. Does anyone know the area of a trapezoid? Got part of it. That's correct. Yep. The area is 1/2 base of 1 plus base of 2 times the height. In other words, if you took the bases, add them, and then divide by 2, in other words, finding the average of the average length of the bases times the height. The reason this works out too, again, if I took this and I duplicated it, flipped it around, I'd have another parallelogram where the base would be, each base would be x plus 6 plus x plus 2. But it's half of that. All right, so let me go ahead and see you guys do this as an exit ticket.